We're going to be evaluating functions using synthetic division, also called synthetic substitution in this aspect of it. And then use the factor theorem to determine factors of polynomials. We did that a little bit already last week with synthetic division. So the remainder theorem. Okay. So when you have synthetic division, I'm not going to be talking over you. So when we have synthetic division, so for example, if we have evaluating p of x when x squared minus 4x plus 7 when x equals 5, usually we just plug 5 in and then simplify it down. If you use synthetic division, you would use that same number. You don't have to change the sign or anything. Bless you. Use synthetic division with that number. The remainder is that same answer. So it's a little bit faster, especially if you don't have a calculator. But you do need to do it both ways sometimes. But we're going to be applying the remainder theorem today. So that's synthetic substitution. And it can be more convenient, especially when the degree of the function is greater than 2. So you might have a 5th degree polynomial. That's a lot of simplifying if you have to plug it in multiple times. Okay. So if you see it worded like this, so using synthetic substitution to find f of negative 3, we're going to essentially divide by negative 3. Right. So negative 3 goes on the outside of your synthetic substitute or synthetic division box. Is anything missing? The x to the third. So we have a negative 2 first. So that's the x to the fourth. X to the third would be 0. X squared is 3. X to the first is negative 15. And we have 9. So make sure everything's there. So the remainder on this one is the answer. So there's a difference between divide using synthetic division and use synthetic substitution, which is very similar. Bring down the negative 2. You guys tell me what to do.
Multiply negative 3 times negative 2.
And that'll give us positive 6. Okay, so negative 3 times negative 2 is positive 6. 0 plus 6. 6. Then again, multiply negative 3 times 6. Negative 18. What's 3 minus 18? Negative 15. Negative 3 times negative 15. 45. Negative 15 plus 45. 30. And negative 3 times 30. Negative 90. 9 minus 90. Negative 81. Alright, now negative 81 is the answer to this because of the way it's worded. So it's not asking you to divide. Synthetic division is just a way we could do that. So negative 81 is what f of negative 3 is. Now you could check that as well. If this were a test, that would be a good idea, but you'd have to use synthetic substitution if it were a test. So if you did check it, f of negative 3, that means you're plugging it in everywhere there's an x in the original problem. We've done this before. That would all come out to negative 81 as well. So you could check to make sure that you did that right. But if you were doing it by hand, synthetic substitution is a little bit faster. Questions? Same deal. Now it's a new equation with 8. I want to see how you guys do on it. Let's see if we can all get the same number. So we have 8 on the outside. Nothing's missing. So we're negative 6, positive 52, negative 27, and negative 31. You are solving for what the remainder is. Anyone have an answer yet? Or can we not add and subtract?
It's really rough.
Happy Monday. Waking your brains up. You have an answer, Casey?
I do.
We have -1. So we have a -1. What else?
I got
9. What else?
I got 9.
Okay. 8 times -6. -48. 52 minus 48. 4. Okay. If you can't do that first subtraction properly, the rest of it's going to be wrong, so be careful. 8 times 4. 32. -27 plus 32 is 5. 8 times 5 is 40. And -31 plus 40 is 9. So, f of 8 would equal 9. So, if you guys are doing this in your homework and you're getting the answers wrong, okay, maybe plug them back in to check. So, if you plug in 8 everywhere there's an x, and you use your calculator to simplify, it should give you 9. So, it should equal the same thing. If you're doing it by hand, synthetic substitution is a little bit faster. Question before we continue? Yeah.
Can you show how you get how you can check?
Mm-hmm. So you plug in 8 everywhere there's an x. So you would find 8 to the third first, then multiply that times -6. 8 squared, 64 times 52, so these are gonna be big numbers. So yeah, then you add and subtract all the way across, you should get 9. Anything else before we move on? If it says use synthetic substitution, you do need to do it, but I do want you to focus on that aspect of it today. All right. We're very chatty today. Rein it in. When a binomial divides evenly into a polynomial, the binomial is a factor of the polynomial. We did this a little bit last week with long division. It was, is it a factor, is it not? If there's no remainder, yes, it's a factor. If there is a remainder, no, it's not. The quotient of that division is called a depressed polynomial. The depressed polynomial has a degree that is 1 less than the original polynomial. Special case of the remainder theorem, which we just use on the front, is called a factor theorem. All right, so I'll ignore the words. If we were dividing this larger polynomial right here, let's say by x plus 6, if we get a remainder of 0, we would get x squared minus 7x plus 12. Since this one has a degree 1 less than this one, this is what it's called, talking about with the depressed polynomial. I don't need you to remember that necessarily. But since that would have a remainder of 0, no matter which way you divide it, both of those would be factors. Sometimes you can factor this one further to get 2 more. Okay. So we are going to be doing that a little bit with these last couple. So show that x plus 8 is a factor of 2x cubed plus 5x, plus 15x squared minus 11x minus 24. Then find the remaining factors. So it's asking you to prove that the remainder is 0. Now telling you can use long division if you want to. I'm guessing you would rather use synthetic. Okay. So, on the inside of the box, is anything missing starting with the third power? No. So we have a 2, x to the third power, 15, -11, and -24. We are hoping to get a remainder of 0. That's the idea for these ones. If you're showing that that is a factor. What number goes out here? It's like -8. So the difference is on the front, it said find f of a certain number. It already gave you the number. This one, if you remember from last week, you would set your divisor x plus 8 equal to 0 and isolate x to figure out what that number is. So x equals -8, that is where that number comes from. So there's a difference between what we did on the front versus what we're doing back here. If we bring the 2 down, what's -8 times 2? -16. 15 minus 16. -1. -8 times -1. -11 plus 8. -3. -8 times -3. 24. So remainder is 0. Okay, so that would prove, so this is your evidence that that is, x plus 8 is a factor of that. Sometimes it's your only way of factoring, which is why they kind of go together. So we now have, how do I write this as a polynomial? So you start with the -3, that's the power of 0, which means no x. This is x to the power of 1, x to the power of 2. So that would be 2x squared minus x minus 3. So with no remainder, that proves x plus 8 is a factor. We need to continue factoring that to find the other 2. How do you factor 2x squared minus x minus 3? A times c, which is what? -6. What factor of -6 have a difference of 1? 3 and 2, which one's negative? 3. What do we do with those?
2x
You have to factor by grouping because a is not 1.
I'm figuring it out.
2x squared, do you guys want to do the minus 3x first or the plus 2x?
Plus 2x.
Can we group them and take out the GCF of each group? Okay. Hopefully some of us are not in denial that factoring is going anywhere. It's not going anywhere. GCF is 2x. What's this one? -3. We take out the 2x. What's left? X plus 1. Take out the -3.
X plus 1.
So this part, okay, so this whole portion factors into an x plus 1 and a 2x minus 3. Okay. But we also proved that that one was the original factor, the x plus 8. So this whole polynomial, there's no shortcut to it, so sometimes you have to use this to get there, would factor into that additional x plus 8 with it. So these are your 3 factors. This is the one you started with, these are the other 3. So we technically divided it out to get the 2x squared minus x minus 3. Because this is not a special type. Question on any part of it? Are you sure? It's the same instructions for the last one, just different polynomials. If you think you have it, work faster. Again, you're trying to get a remainder of 0 on these with the instructions, so show that x minus 2 is a factor of 3x cubed plus 10x squared minus 27x minus 10. So you want a remainder of 0. If you're not getting one, you are doing something wrong, because these are supposed to work out that way. What number goes outside? Positive 2. It's the opposite sign, how it appears in the factor. So x minus 2 is supposed to be a factor, and then we'll likely get a couple more. 2 times 3 is 6. 10 plus 6 is 16. 2 times 16 is 32. Negative 27 plus 32 is 5. 2 times 5 is 10. Negative 10 plus 10 is 0. So, yes, it factors, or x minus 2 is a factor. That polynomial, the rest of it, 3x squared plus 16x plus 5. We need to factor this to get 2 more. There's no factoring shortcut on this one. What's a times c? 15. What factors of 15 add up to 16?
15 and 1.
15 and 1. Doesn't matter which one you put where, but we have 3x squared, I'm gonna do plus a 1x, plus a 15x, plus 5, you can switch them if you want. In this order, the GCF on the first group is x, second one is 5. You take out the x, you have 3x plus 1. Take out the 5, you have 3x plus 1. So our factors are 3x plus 1, x plus 5. And then the third one is the one we started with, x minus 2. So you can write all three of them together, but just know this one was in the original problem. Alright. So that would be the remainder theorem on the front, which is if you plug in a number, it's the same thing if you divide by it with synthetic. Factor theorem is proving that there's a factor, but the remainder is 0. Questions? If you understood synthetic last week, this shouldn't hopefully not be difficult.